What if there was a way we could directly remove harmful carbon dioxide from our atmosphere? Could such a technology change the future of our planet? Welcome to the world of carbon removal technologies. These are innovative solutions designed specifically to extract carbon dioxide, one of the primary greenhouse gases, straight from the atmosphere. These technologies are not just concepts, they are tangible tools in our fight against climate change. Today, we explore a series of innovative carbon removal technologies that may just hold the key to our planet's future. Ever heard of direct air capture, also known as DAC? It's a fascinating technology that uses intricate chemical processes to capture carbon dioxide directly from the air around us. Imagine a giant vacuum cleaner, but for harmful greenhouse gases. The benefits? It has the potential to significantly reduce atmospheric CO2 levels, playing a crucial role in our fight against climate change. However, despite its promise, it's important to remember that DAC is only one piece of the carbon removal puzzle. Next up, we have bioenergy with carbon capture and storage, or BECCS for short, and enhanced weathering. Let's dive right into BECCS. This technology is all about capturing the carbon dioxide produced by biomass power plants. Instead of letting it escape into the atmosphere, this carbon dioxide is stored deep underground, effectively removing it from the carbon cycle. Now let's move on to enhanced weathering. This process uses either natural or human-made minerals to capture carbon dioxide. How? It's all about chemical reactions. These minerals react with carbon dioxide in the air and form stable compounds. The result? A lower concentration of this greenhouse gas in our atmosphere. Both BECCS and enhanced weathering offer attractive benefits. They provide a way to not just limit but reduce the amount of carbon dioxide in the air. However, like all technologies, they also come with their own challenges. While BECCS and enhanced weathering offer exciting possibilities, they also come with their own challenges. But what about the power of our oceans and forests in carbon removal? Indeed, let's not underestimate the role they play. Ocean-based solutions, for instance, harness the power of seaweeds and other photosynthetic organisms that naturally absorb carbon dioxide. Picture this: vast underwater forests teeming with life, silently scrubbing our atmosphere clean. On the other hand, afforestation and reforestation involve the seemingly simple act of planting trees. And yet, this process is one of the most effective carbon removal techniques we have. Each tree we plant is a natural carbon sink, capable of absorbing and storing vast amounts of carbon dioxide over its lifetime. These natural solutions are not just efficient, they also bring along a host of other benefits. They support biodiversity, help regulate local climates, and contribute to the health and well-being of communities. The natural world offers us some of the most effective tools in the carbon removal toolbox. Lastly, we delve into carbon mineralization, carbon farming, and direct ocean capture. Carbon mineralization is a fascinating process that transforms carbon dioxide into solid minerals. This happens naturally over thousands of years, but scientists are now finding ways to speed it up, potentially locking away CO2 for good. Moving on, we have carbon farming. This isn't your usual farming. It's a method that uses sustainable farming practices to sequester or capture carbon in the soil. By changing how we farm, we can reduce the amount of CO2 released and even capture some of the existing CO2 in the atmosphere. Lastly, there's direct ocean capture, a process that involves capturing CO2 directly from seawater. This is a promising technology, given that our oceans absorb about a quarter of all CO2 emissions. Each of these technologies brings us one step closer to a more sustainable future. So, can carbon removal technologies really change the future of our planet? From the direct air capture that scrubs CO2 from the air, to bioenergy with carbon capture and storage and enhanced weathering that transform and store carbon. Ocean-based solutions, afforestation and reforestation absorb CO2, while carbon mineralization and farming sequester it in the earth. And let's not forget direct ocean capture, extracting carbon straight from seawater. Ultimately, the answer to our opening question lies in our collective effort to adopt and advance these technologies. The future of our planet may very well depend on it.